In this video, we are going to talk about building quadratic models. There are many situations that can be modeled with quadratic functions. The path of a baseball that is thrown into the air, maximizing profit, maximizing area, and other things. In these problems, you will be responsible for building the model and then using that model or function you have created to solve problems. Example 1. The sum of two positive numbers is 28. What two numbers will maximize the product? So I'm going to take you through a step-by-step guide for building a model to solve this problem. So in step 1, we're going to let x equal one of the numbers, and we'll let v equal the other number. And the first thing we're going to do is write an equation that relates x and v using the information about their sum. And it tells us that the sum is 28. So we can say that x plus v is equal to 28. In step 2, we want to solve the equation that we wrote in step 1 for v. So I'm going to subtract x from both sides, which will leave us with v is equal to 28 minus x. Now in step 3, what we're going to do is write a function in terms of x to represent the product of the two numbers, because the problem we're trying to solve is that we want to know what two numbers will maximize the product. So I'm going to put this in terms of a function. So f of x is equal to one of the numbers is x, and the product would be times v. But if this is a function of x, I only want to have x as a variable over here. So I know that v is equal to 28 minus x. So I'm going to take that and put it in place of v. So that will give me a function, f of x is equal to x times, 28 minus x. So that is the product of those two numbers. Now in step 4, we have a function now with one variable being x, and we want to determine whether we are looking for where the x-intercepts are or where the vertex of the function is. Now if we're asked to maximize the product, the term maximize is an indication that we are looking for the vertex. So if you ever hear maximum or minimum, that is a clue that you're trying to find the vertex. So if you remember, the vertex of a function is negative b over 2a. So I'm going to take my function and I'm going to put it in standard form by distributing this x to both the terms inside. So x times 28 will give me 28x, and x times negative x will give me negative x squared. And now if I put this in terms of descending order, I have negative x squared plus 28x. So if I'm looking for the vertex, I know that I have the x-coordinate of the vertex being negative b over 2a, and the y-coordinate of the vertex is f of negative b over 2a. So I'm looking for x here. I know that a is equal to negative 1 and b is equal to 28. So that will give me negative 28 over 2 times negative 1, which is negative 28 over negative 2, which gives me 14. So since I was looking for the two numbers, x equals 14 is one of those numbers because that's what I assigned to x at the beginning. And then if x is 14, remember that v is equal to 28 minus 14, which in this case is also 14. That won't always be the case, but for this problem it is. And so my two numbers are x is 14 and v is equal to 14. And when we add those numbers together, we do get 28. And when we multiply those two numbers, we get the maximum product, which is 196. But the answer to our problem is v and x are 14.